Suppose we want to collect sample data in order to estimate some population proportion. Well, how do we determine the sample size we need to use? We'll start by deciding on the margin of error. How many percentage points do you want to be confident about within, have a certain confidence that you're within so many percentage points? So these types of problems involve these given items. The margin of error, that's given, decided by the researcher. They'd like to be within 2 percentage points, 3 percentage points, whatever. The second thing that they would have to have is either an estimate of p hat. Maybe they got a previous study or someone else did a study and they have some estimate of this proportion in the population. Or if you don't have an estimate, you just use 0.5 for p hat. And finally, you need to decide on your confidence level. And if we have those things, then we can calculate in the sample size required. Now remember, we'll be working problems, so these are the things that we need to think of are going to be given to us. We should be given this margin of error, either an estimate of p hat, or we'll use 0.5, and we need to be given the confidence level. And with that information, we can then calculate the sample size required. Okay, so let's look at the formula we already know for margin of error. Remember our E formula. So we have our critical value. We get that directly from this confidence level. A certain confidence level tells us what critical value to use, times the square root of p hat times q hat divided by n. So what we've just said here is we have E. That'll be given, so we'll have E. We'll have p hat, or if we don't have an estimate for p hat, we'll use 0.5. And then of course we get q hat by saying 1 minus p hat. So either we'll have an estimate for p hat and we'll say 1 minus p hat to get q hat, or if p hat's 0.5, then q hat is also 0.5. And then the confidence level, and then our n, of course, is what we're trying to solve for. So we have all the parts except n. So one way to deal with this is to rearrange our formula using algebra to get n by itself, because that's what we're solving for. That's the thing we don't know. So what we could do to get n by itself, well, I would like to get rid of this square root here. So I'm going to square both sides of my equation. What I'm doing here is showing you where this formula for n comes from. Okay, it's just directly from something we've already learned about. So when I do that, and I don't know why I put the square there. Obviously it would be right here. Talking and writing at the same time. Okay, there we go. So now we have our margin of error squared on the left. Now what this means is I square both parts. I square the z alpha over 2 and I square this radical. So I have z alpha over 2. This gets squared. And when you square a square root, you just eliminate the square root symbol. So this is times p hat times q hat all over n. So now what we've done, by doing that, we got rid of the square root. Now what I'm hoping to do is get n by itself. And right now it's in the denominator, so I'm going to multiply both sides of this equation by n. This side by n and this side by n. Okay, when I do that over here, I have what? E squared over n, times n, times n, not over n, because we multiplied right here. Now over here, notice what happens to n. These n's cancel out. So all I have left is z alpha over 2 squared times p hat times q hat. Almost there. What I want is n by itself. So the next step will be to divide both sides by the margin of error squared. So if I divide this side by the margin of error squared, it's going to cancel. Divide this side by the margin of error squared, and this is my new expression, or my new equation. So n is equal to my critical value squared times p hat times q hat all over the margin of error squared. So it's not a new formula, it's the same formula. We've just rearranged it to solve for n, because this is what we're looking for now. Okay, now we need, before we work an example, let's talk about rounding for n. So the round off rule we'll get some calculation for n, and say we get 100.1. Okay, that means we should survey, or we need to poll 100.1 people to have the confidence level that we said we want, and within the plus or minus percentage points. Well, if we obviously can't survey 100.1 people. If we round that down, our normal rounding would say, well, that rounds to 100, then we will not be as confident, because now we're not surveying enough people. We needed not 100, but 100.1. So in order to have the confidence that we have built into this problem, we always have to round up. We would need to survey 101 people. It's a little more than we need, but we can't go less than we need. Okay? So we always round up to the next whole number. Always round up. Okay, that's the round off rule for n. Okay, let's work an example. All right. The nation's economy is an important issue to most Americans. So a pollster wants to determine the current percentage of Americans who report hearing mostly bad news about the economy. How many adult Americans must be surveyed in order to be 95% confident that the sample percentage is in error no more than 3 percentage points? This is where they're giving me E. E is equal to 3%, but now we have to use it as a decimal in our calculation. Don't forget that, 0.03. That 95% confidence, remember, that means we have a Z, alpha over 2, so Z 0.025, because our alpha is 0.05, and recall that is 1.96. Okay, so we know that. Now, we're going to do this in two ways. Our first part, in part A, we're going to use results from a previous poll. Let's use results from a previous poll maybe the month before they did this, that found p hat equals 0.35. So they found 35% of the adults, American adults, felt that they were hearing mostly bad news about the economy. Okay, so that tells us now we have a p hat of 0.35 and a q hat of 1 minus 0.355. I was thinking of my next number, or 0.65. Okay, so our equation, recall, was n equals critical value squared times p hat times q hat all over margin of error squared. And we saw where all that came from. All right, so let's put this stuff in. 1.96 squared times, I'm going to put in parentheses, 0.35 times 0.65 all over, now that 3 percentage points, 0.03 squared. Okay, run this through your calculator and you get 971.07. So the n we need to, the pollster, I guess, it wasn't us, but we can say the pollster should survey 972 people. If we say 971, we will not have the confidence that we have built into this. That's lower, and we'll be dropping down and not quite have the confidence. So it's better to round up. 972 people. All right, so that's one way. We said either we have some kind of previous information about p hat, or if we don't, we just use 0.5. So assume no prior information. First time we've done this research, they, or the pollster has. No prior information. When we know that, we know that what we have to do then is say p hat equals 0.5, so q hat equals 1 minus 0.5, or also 0.5. Okay, so now our n is equal to 1.96. I'm using the same formula. What's changing is my p hat and q hat, and sometimes you may see that this is already written in the formula as 0.25, because that's 0.5 times 0.5, so they just put 0.25 right here to begin with. Okay, all over 0.03 squared. Okay, this time we get 1067.11. So we would say the pollster should survey 1068 people. Always round up. Now the thing about not having an estimate for P, this is going to be very conservative. In other words, it's always going to give you more, a larger sample, more people to survey than if you have some kind of estimate that's not 0.5. So this is like the most conservative. And what you would do if you don't feel very good about your previous information, or you really just don't have it, then this is the way to go. So we've seen both types of problems. Okay, so this is about calculating sample size for creating a confidence interval estimate of the proportion.